Hello again and welcome back to another physics lab. This week's lab is rotational equilibrium. In other words, we're finding balance between one or more torques. That is, torques that should be equal and opposite. The same amount of counterclockwise rotation as there is clockwise rotation. To start getting this experiment set up, you need to find a way to suspend a meter stick. That is, we're going to tie a string around a meter stick and dangle it from something. I typically use a hammer because it's got a nice heavy head. I can tie one end of my string around the handle, hang it off over a ledge of a table, and then my meter stick will dangle below it. Once your meter stick is dangling, you will find its balance point. You will shift it side to side until it balances on its own. And that actually will be the first thing you'll record in your data table. The balance point should be close to the middle, but it is rarely exactly the middle. In fact, here, it's not right at 50 centimeters, but just slightly to the left. My balance point would be about 49.7 centimeters. We want to convert that to meters, so we would record that as 0.497 meters in our data table. However, yours may be different than mine, so you will not use that number. Once you have your meter stick suspended from some sort of string, again, I used a hammer, but you could just as easily have used something like a wooden dowel with a book stacked on top of it to hold it in place. Once we have our meter stick suspended, we need to prepare our masses. We need masses of 100, 150, and 200 grams, and it is recommended to use pennies and nickels to total up to these masses. Pennies and nickels have known masses. Pennies are 2.5 grams each, nickels are 5 grams each. So you could get 100, 150, and 200 grams with 40, 60, and 80 pennies, or alternatively 20, 30, and 40 nickels. You could use some combination in between. You could use some other objects entirely, as long as you know their masses and you know that they are 100, 150, and 200 grams. I like to place mine in Ziploc bags, and then I poke a paper clip through the corner of a bag to make a nice, simple hanging mass. Following along with the lab report, the lab instructions, you'll place known masses at specified locations. You'll start by placing one mass, you'll then move on to placing a second mass, and then in a third trial, you'll actually do an unknown mass. But let's follow along as if we were doing the first section of the lab. We would place a single mass at a known location, a known mass at a known location, and it tells you to place it at the 10 centimeter mark. As soon as that mass is hanging, the torque is not balanced. We are not in rotational equilibrium. So I must hold one side of the meter stick. You'll then take another known mass and place it somewhere on the opposite side. You'll need to slide it back and forth until you find rotational equilibrium. You'll know you've found rotational equilibrium when one side does not go up or down. It's okay if your meter stick is at a slight angle, as long as it isn't tipping up or down. I seem to have found it there, and I would now record lengths to mass 1 and mass 2 from the balance point. Mass 1 is placed at 10 centimeters. If my balance point was 49.7 centimeters, my length is not 10 centimeters, it's not 49.7 centimeters, it is the distance from 10 to 49.7 centimeters. That would be 39.7 centimeters, and I would convert that to meters, 0.397 meters, and record it in my data table as L1, the length from the balance point to mass 1. Similarly, we would find L2, the length from the balance point to mass 2. 49.7 to what I found to be 91.6 can be found as 91.6 minus 49.7. It would be 41.9 centimeters, but again, we want it in meters, so we would record it as 0.419 meters. Those numbers are not what you should record. You will do this on your own, record your own numbers. But that is the process for how to set this up and how to properly take data. The most important thing to remember is, again, to measure from the balance point. Do not record the actual location of your masses, but instead their distance from the balance point. As usual, if you have any questions about the setup or the calculations involved with your experiment, reach out to your professor for clarity. That's all for this week. See you guys next time.